Good morning, Ananda. Myself Bhavani from Civil Department. Today I am going to tell you about how these earthquakes can be measured, by what methods we can measure these earthquakes. In the last class I have told about the types of earthquakes, how that earthquakes can be caused and what are the devastating effects of the earthquakes. Today we are going to discuss on earthquakes, how it can be measured. Coming to the first one, firstly, why these earthquakes have to be measured by, because if this measure means in the next pre-coming years, we can come to know that how much of the magnitude it is going to occur and how much of at what intensity it can occur. Likewise, here we are having some instruments here. What are that instruments according to the magnitude and also these intensities? Coming to the first one, that is magnitude measurements. In this magnitude, Richter scale, it is the first one. Mainly, how this Richter scale can be determined and who invented this means. Firstly, it is developed by Charles F. Richter here in the year 1935. Mainly, this Richter scale, it is designed to provide the qualitative measure. Means when any earthquake means earthquake occurred means how much size and how much area it occurred and how we have it provided the overall qualitative measures. Means if you are going to determine these earthquakes means at what time it is occurred and how much area it occurred and how much depth it occurred, we are come to know because of this Richter scale only. Here they will give only about the qualitative measurement of the earthquake size here. Means how we are going to calculate this Richter scale means here you can see the formula ML minus log 10A minus log 10 A naught delta. Means this is the basic formula to know about the Richter scale. Means how we are going to calculate this earthquake size from using this formula. And mainly here you can see the formula. In this one, A is nothing but the maximum amplitude of the seismic waves here. Means we have to measure the this A nothing but the amplitude of that seismic waves we have to measure. And next one is A naught delta. It is nothing but the calibration function that have to be depend on the distance of this delta from the earthquake to the seismograph. Why? Because when these earthquakes, we have to keep these seismometers here and there. Why? Because in some areas like Japan, already we know that in that areas, earthquakes will be very, it is common to get earthquakes in that Japan country. But when we are going to measure that earthquake, at how much intensity it occur means, these seismometers we have to provide here and there of that area. Then only we have come to know at what time it occurred and what at how much intensity, how much magnitude it occurred. We have come to know because of this seismometers also. But in this Richter scale, we have to measure the magnitude here. Means when these by using this formula only, we have come to know this Richter scale, how we have to calculate. Okay. Next one is logarithmic nature. Means here we are going to calculate the earthquake magnitude using the Richter scale. In this Richter scale, we are going to calculate in the logarithmic nature. Means here we have to mainly this Richter scale, it is represents the tenfold increase in the overall measured amplitude and approximately 31.6 times more energy released. Means here we are going to calculate everything in the logarithmic nature only. You can see the figure here, that is figure number 1. Here x-axis is magnitude and this y-axis is the Richter scale here. Means if the magnitude is less than 2 means that have to be told that it is not felt earthquake. Means if heavy earthquake it occur means that will be at the ratio of 7 to 8 and 7 and above magnitude, if that type of earthquake occur means that is said to be the very major earthquake or very great earthquake here. Here you can see the ratios here. Means from 0 to 3 it is not at all felt, and 4 to 5 it is nothing but the minor earthquake, and the next is 5 to 6 it is moderate, 6 to 7 it is somewhat strong. Means buildings may be very weak buildings, they may collapse at that time, and next one is 7 to 8 and 8 to 9. These two are the very major earthquakes which will just wipe out the overall area. Okay. And next one is in this magnitude measurement only. Means in this magnitude, second one is moment magnitude scale. In this one, we have to hear what it will determine. Means to provide more accurate and consistent measurements of these earthquakes which having the magnitude above 6. If the magnitude is above 6, then we have to use this type of we have to use this type of scale here. And in this one also, moment magnitude scale is calculating using the formula of MW equal to 2 by 3 log 10 into M0 minus 10.7. And here M0 is nothing but the seismic moment. Means when this earthquake is going to occur, no, that moment, the seismic moment, we are going to call it as the M0 here. And separately this M0 formula is mu into A into D. Here mu represents the rigidity of the rocks involved in the earthquake. Means when an earthquake is occurred, overall means earth surface is going to change its faults and folds at that time. Means at that time only we have to calculate this mu value. Means we are going to get this mu value at that earthquake causing area only. Means how much rocks it involved when an earthquake is occurred. And next one is area of the fault, and D is nothing but the average slip on the fault. Means when these earthquakes, overall rock to rock earth surface will be there. When an earthquake is going to occur, means there will be so much slipping on the fault. Means rock to rock, they will just some of them they will break down at that time, and some will be just losing its balance and fall down at that time. Like this only earthquake is going to occur. 6 to 9 earthquake, that much magnitude earthquakes, we have to follow this moment magnitude scale here. Next one is what are the advantages. Means when we are using moment magnitude scale, means other than this Richter scale, we have some advantages here. Here by using this moment magnitude scale, we are going to get the consistent measure of the earthquake size of any location, any fault types or any magnitude also. Means if its magnitude is normally only, if less than 2 also we are going to get the results here. Means in this scale we are going to get these results. And overall when compared with Richter scale, this one is far better than the Richter scale here, because it is going to provide the overall data. Means which location that earthquake occurred, and at what is the fault type it is occurred, and what is the magnitude, at what magnitude it occurred. It will provide everything here. And here so that's why it is much more preferable, and it is one of the modern seismology instrument or tool we are using nowadays. And next one is intensity measurements. Means after completion of the magnitude measurement, in magnitude measurements we have two types, that is Richter scale, and next one is moment magnitude scale here. And coming to the next one, that is intensity measurement. Means here we are going to calculate the intensity, at what intensity this earthquake is occurred, and what is the nature of that occur. And here also we are having the different types of scales here. First one is modified Mercalli intensity scale, and in this one what we are going to measure here means it will measure the qualitative measure of the effects on earthquake on earth surface, and also structures, and also humans. Means after completion of this earthquake, we have to measure how much the people they died and how much magnitude that earthquake is occurred. We have to know everything. So this type of scale, it will just measure the effects, means what are the effects when an earthquake is occurred on the, whether it may be structures or whether it may be humans or whether it may be at the surface. We have come to know because of this modified Mercalli intensity scale. And how it is going to be measured means, mainly it will range from 1 to 7, means 1 to 7 means one nothing but it that type of earthquake we can't felt also, but 7 here you can see this one, 1 to 7 earthquake here they have given. In this one, that type of earthquake it is not at all felt, but whereas this seventh one, when its overall scale range is 7 means it nothing but the seventh scale is nothing but the total destruction of that area. Means this each level it will be defined by the specific observations of both the damage and also the human perception. Means damage means what it is, where the damage is occurred means whether it may be infrastructure or whether it may be high-rise buildings or whether it may be bridges and also skyscrapers also. Why? Because when any earthquake occurs means it will collapse everything in that area. If that overall scale will be ranging from 7 means it will just wipe out that area. Means some of the areas both earthquakes and also tsunamis can be occurred at that time. Okay, so this MMI scale is very much better with respect to intensity measurement here. Means how we are going to measure means how it can be measured and how it will be felt means mainly we can't felt anything. Means if it scale ranges is 1, it's nothing but it cannot be felt by any few conditions. Means some favorable conditions it cannot be felt also. Means when it is occurred also, indoor people or outdoor people during the day also, overall just walls may be break at that time and so much disturbances can be made at that time when these earthquakes can be occurred. And also if some of the constructions like bridges, skyscrapers or also high-rise buildings, when these are constructed with a good design and analysis of that one means there will be that type of damage is somewhat negligible in that type of buildings. But slight to moderate is in well-built ordinary structures. Means there will be some moderate earthquake can be occurred in the well-built ordinary structures, and some will be very poor built that can be destructed easily. When any small natural hazard occurred also, if that building is very poorly, means very poor materials they are used means automatically that will going to be destructed. And total damage it is going to be occurred and also deserted also. Objects, when these earthquakes occurred means objects will be thrown into the air and also lines of sights and also level can be deserted. Like this MMI scale is going to be occurred when this earthquake is occurred. And if the magnitude, if the intensity of that earthquake is almost this one 12 means 1 to 12. 12th is nothing but the total destruction. And here if that one is 12, up to 12th scale it occur means it is one of the very severe earthquake that occurring at that time. And how we are going to use this with this type of earthquakes, how we are going to use this MMI scale means it will be mainly, the scale is mainly depends or based upon the surface surveys and also observations which we are going to collect from the people who experienced that earthquake. Means when any earthquake occurred means at that place only some people can see, means they can see and they can how they felt, they can tell everything. When we are going to just survey that people, they will tell everything. So from that people only this MMI scale can be based upon. And also mainly this scale is providing very valuable data for the accessing of the impact of different areas. Why? Because in some area, maybe it will occur up to 7 scale. Maybe in some areas, means zone 5, like that, buildings, earthquake zone 5 will be there, means of course in that area so much of intensity scale can be raised, means if the intensity scale is up to 12, means it will be very severe earthquake. So when we come to know or survey the people in that areas who experienced that earthquake only, we can provide the valuable data there. Means in different areas, maybe intensity scale can be varied here. So what is the impact on different areas? We have come to know by surveying the people who experienced that earthquake here. See here, this one is one of the modified Mercalli intensity scale. Means how we are going to determine that one. Means if the intensity is 1, means it cannot be felt, and also it cannot be felt, or it cannot be, means in favorable conditions also it cannot be, we can't felt that one. And next one is if the intensity is 2, it will be weak. And how we are going to felt, means some of the people, they may just slightly experience that feel, means upper flooring buildings, there will be cracks forming on the walls. And likewise up to 12 intensity scale we are having, means up to severe conditions, these earthquake can be measured in this MMI scale here. Next one, means after intensity measurement, after magnitude measurements, here is next one, that is instruments and data collection. Here we are having so many instruments. We are just going to keep this instrument in that earthquake zoning areas, and then only we have come to know them, means at how much magnitude it occurred and what is the motion of that at the surface when this earthquake is occurred. Everything we have come to know because of these instruments here. While in these instruments we have 2 types, that is seismometers and also seismograph. And how these seismometers can be occurred, means mainly these type of tools or instruments, they can detect and also measure the motion of the ground, which is ground surface, which can be caused due to this seismic earthquakes here. Means mainly this can be mainly it will relate to the bedrock, which is accurately it capture the ground moments. Means if you are going to keep this seismometer on the ground surface, when earthquake is occurred, means it will automatically detect, and it will without any order also, it will just measure the overall ground surface measurement, and how the change in bedrock is going to take place. It will tell everything. And mainly next one is seismograph, and how these seismographs can be easily recorded, means mainly it will be recorded by the seismographs or seismograms. This seismogram, it is nothing but the graphical representation of the seismic waves. Means when just it will record like this, means like this it will record. Why? Because when we are going to place this type of instruments on the ground surface, if earthquake is occurred, means it will automatically write down the overall graphical representation. Means magnitude it will note, and how much intensity it is going to be occurred, everything here they will note here. And mainly this will show the amplitude and also frequency. Here amplitude they will say, and also frequency we can note here. Means in this one only, in this seismograph only, earthquake, at the time of earthquake occurring time, only this will be going to be takes place, and the graphical representation like this we can see this one after the earthquake completion. And what are the main components required for this instruments? Means modern seismometers, these are very sensitive and can detect the wide range of frequencies here. Here you can see the picture of seismometer. Means here you can see this seismometer is placed on the ground surface here. By placing the this seismometer on the ground surface, we have come to know everything, means seismic waves, how it is started and how much magnitude it is started and what is the impact of that one. Overall, this will show in the graphical representation only. Okay, and here mainly this type of seismometer, they often consist of three components. Why these three components and what will they will do means it will measure the overall motion in the three perpendicular directions. Means any earthquake is occurred means automatically it will going to be that ground surface. On the ground surface only we are placing these instruments here. Means how this going to be noted means it is going to be noted in perpendicular directions. Means vertical direction it is going to be meet, and the north south direction and east west direction it is going to be measured because of this seismometers and also seismographs. Next one is seismic networks. Means if we are going to provide the seismic networks, means what is the purpose and how we are going to use these seismic networks. Means mainly it is consist of multiple seismometer stations which can be distributed among that region also. Means for suppose if this Hyderabad is the some region in the this Hyderabad is the some zone 4 or zone 5 region, means these meteorological people, they will just keep these seismometers here and there. Why? Because of this networks, because of these seismometers only, seismometer stations, we are come to know, or they will, these networks, they are going to be provide the overall coverage and allow of that area for the precise determination of the earthquake characteristics. Means by placing these seismic meter stations here and there of that area, we are come to know the overall determination and how much area it covered and how much people they died. Here they are going to tell everything, and also earthquake characteristics also we have come to know because of this one. And triangulation, nothing but it is here we are going to measure this earthquake in the P waves and also S waves. Here we are going to compare this when any earthquake is occurred, means arrival time of this seismic waves at a different stations. Then these seismologists, they can just triangle the epicenter of that one, and the depth of the focus is can be determined by using this arrival times between P waves and also S waves. Means by using this overall triangulation method, we have come to know this at what where these seismic networks can be provided, and when we are going to provide these networks, what it will happen and how much useful it is, we are come to know because of this seismic networks. Means we have to provide some stations. Means seismic meter stations we have to provide, then only we have come to know the magnitude and of course at what intensity it occurred, everything we are going to know at that time. Means like this, here you can see, means everything here is overall digital broadband of seismic networks here from overall the world. Means here you can see the region, this red star, it is nothing but the Iris, and triangular green is nothing but the France. Likewise here you can see, means these red dots, red star dots, and also triangular green, everything they are nothing but the different stations these meteorological people they will provide overall the world. Next one is also we have to provide this GPS system. Means it is one of the best seismic network area. Why? Because by using this GPS we have come to know the, means it will be equipped with the receivers here. Means after fixing these GPS stations, we can measure their precise positions with respect to the satellites. Means there will be direct connection to the GPS and satellites. Means any person, if any person or any vehicle is here and there, we don't know anything, but using this GPS also we can know at what time they went and what area that vehicle is there. Means Everything we have come to know because of this GPS. It is nothing but the global positioning system. If we are going to continuously record these type of positions like means where this earthquake is occurred, everything they are come to know. With respect to earthquake, I am telling you why, because in the world means satellites can be provided in the space, means from space our earth is going to be examined because of this GPS here. By using these GPS stations, we can easily predict, we can easily see where this earthquake is occurring and at what time it is started. Everything we have come to know because of this GPS stations. And also by continuously recording, and these scientists also can detect these ground movements with level accuracy also, means in-depth image we can get, in-depth image of the earthquake occurring. We can easily note or we can see easily because of this GPS here. And also mainly what are the applications here we can get by using this GPS is, we can use this to measure the slow build-up of this strain with along the faults also. Means of course in the ground surface faults and folds will be there. When this earthquake is occurred, automatically they will change its position. Means by using this GPS we can measure the overall slow buildment of the strain here along the faults, and there will be sudden slip when this earthquake is occurred. So then only this GPS can detect it. Means this GPS they just identify when this sudden slip of the faults and floats occur, means then we come to know that any that earthquake is occurring in that area. And also post seismic deformation of that crust also adjust at that time. Means because of this GPS we are having so many benefits here. From the space only it is going to be examine each and every part of our earth here, and if there is any change in the faults and folds of the earth surface also, within also this GPS can just send that photo to the meteorological department or a seismologist also. Then they are easily within means after this completion of the earthquake only, these people can know that in this area earthquake is occurring, at what magnitude, everything it is come to know. Means in also this GPS can be measured easily like this. Means satellites are provided, and here in this area here you can see some position. Okay, if this is your position, means of course in this area earthquake is occurring also. From the satellites only we can come to know. Means in this place if I am there in that place, means because of this GPS we come to know. Or any earthquake is occurring also, the satellites can see that one, and they will just send the data to the seismologist or meteorological people also. There is a very much benefit of this GPS. And next one is INSAR. INSAR, it is nothing but the interferometric synthetic aperture radar here. By using this one we can just detect the ground displacement, and this one also we are going to get from the satellite itself. Means from the satellite, that satellite they will just take the radar images. Means if there is any ground displacement also, these radar images will be sent by the satellites to the seismologist or any scientist. Then by comparing this radar images from and after the before and after the earthquake, the scientists can create the detailed image of that surface deformation. Means of course when the earthquake is occurring, means there will be so much deformation of the earth surface here. Means when satellite is going to send that radar images before and after, means this scientists they will just confirm. Means what will happen and what is the ground surface before and what is the ground surface afterwards. They have come to know at that time. And mainly what is the main advantage of this INSAR, means these can cover large areas also, and this can detect very small displacements. in or in micro level also we can see that one. Okay, and this will, because of this insert data only, they are going to provide the understanding fault mechanisms and also earthquake processes here. Means by using this insert data. Of course, insert data and GPS data, these are all comes from the satellite itself. From GPS, each, if the vehicle and also humans and any displacement like earthquakes like that occurred also, that GPS can be measured in also at that time. Likewise, here also in insert network also, we have come to know each and every point of this radar images from the satellites here, and scientists can just compare themselves of this surface deformation. Means this one also it will detect the very small displacement of the earth surface. Means it will be in micro level also or nano level also, it will come to know. Means like this, from the satellite overall, if the area is the surface area is deformed, means of course from the satellite it will come to know everything, it will come to know. Next one is data analysis. Means after the magnitude, after the intensity, after the seismic networks. Next one is data analysis. Means after getting the seismic wave analysis, what we are going to get. And in this one, first one is seismic wave analysis. Here we are having three types of wave types. First one is primary waves, that is nothing but P waves. These primary waves, it is nothing but the fastest seismic waves that will travel through both the solid and also liquid materials here. Means because of this seismic wave analysis also, we can easily measure these earthquakes here. And the second one is S waves. These are very much slow when compared with the P waves here. But these S wave can be travel only through the solids, not in liquids. In P waves, these seismic waves can be travel to the water or rocks also. But whereas the secondary waves, it will travel through the rocks like that only. And the last one is surface waves. Mainly this type of waves that will travel along the earth surface, and this will cause the most damage to the earth surface. And how we are going to analyze this one means, here at various seismograph stations, this seismologist can be determine the earthquake location and what is the depth of that earthquake and what is the magnitude of that earthquake. Everything we have come to know because of this seismic wave analysis. Means by keeping the seismograph or keeping the seismometers also, we can easily predict it watch time that earthquake is occurring and what are the characteristics of these waves and what is the location, what is the depth and what is the magnitude earthquake is occurred in that area. Everything we can see here. And here you can see this is one of the pictorial representation of the seismic wave analysis. Next one is aftershock monitoring. Means when these earthquakes, means when any smaller earthquakes occur, means that will follow the main shock here. Means main shock nothing but here when any earthquake is occurring, monitoring of this overall earthquake can be provide insight into the stress distribution and also of the behavior of that fault. Means we have to monitor everything. When these smaller earthquake is also occur, means we have to monitor everything. Means some of the seismologists, they will just leave that one. Why? Because if the magnitude level is 3 and also below 3, we are not going to consider. Why? Because that is a very small minor earthquake. So they will just leave that one. Means after the completion of that small earthquake also, we have to just note the at what magnitude it occurred and what is the depth of that one. Means everything we have come to know about that earthquake. And also what is a pattern, means how we are going to follow that aftershock monitoring pattern. Means aftershock mainly, typically this will decrease in the frequency and also magnitude over the time. So this will pose a very significant risk here. And historical data and patterns. In this one, we have to keep the historical data of the earthquake. Why? Because we have to compare the earthquake, means from the previous some hundreds of years up to now, we have to compare everything. Means we don't know at what time, at what magnitude, at how much intensity this occurred at that time and at that year. So by taking the historical data, means we have to collect the data when after the earthquake only. After the earthquake, we have to note down and we have to keep each and every data of this earthquake. Then only because of this historical records, scientists can be identify the patterns and also trends of this seismic activity. And next one is seismic hazard assessment. Here we are going to access the, means we have to assessment can be done for this seismic hazard, means we have to assess the seismic hazards. And from this all after the completion of the earthquake only this can be done. Why? Because we have to examine these seismic hazard areas, then we can just develop the building codes and also we can provide them early warning systems for that people who are living in that earthquake zones also. And also next one is measuring of these earthquakes. It involves the combination of both intensity and also magnitude. And also we are going to use here instruments like seismometers, seismographs, and also data analysis we have to get. And also these Richter scale and also magnitude scale also, this will only qualify the energy released, but MMA scale, it will access the impact on the people and also the structures, means they will just survey the overall that area, means they will talk with that earthquake zone areas after the completion of that earthquake. And also these instruments like seismometers, GPS, INSER, everything can be provide the measurement of our ground motion and also the deformation of the earth surface here. And also by analyzing the seismic waves, after shocks and also historical data, we can come to know or we can understand the earthquake dynamics, and then only we can mitigate their effects also. Means now these when any earthquake is occurred, means of course we can come to know that one. Means next year if that earthquake occurred, means we can just we have to think of some idea to mitigate that earthquake here. So we have to provide the people with the early warning systems and also how they can save themselves with any natural hazard is going to be occurred. Everything we have to provide the people and give them the education, because means how they can save themselves and also means at what area they have to just go and stay at that time. We have to educate the people overall the world. Then only people and also infrastructures they can save themselves from the earthquakes or also any natural hazard also. Okay, these are the reference books I have referred. You can also measure. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.